Alright, so here is our final being John Napier problem. We are going to use the power property to raise 24 to the 7th power. So I'm going to start by just writing that down, 24 to the 7th power. Could you imagine doing that by hand? 24 times 24 times 24 times 24 times blah, 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 blah. It'd be a pain. So this will make our life a lot easier. We're just going to take the log of this. Now, a log of a power, I get to take that 7 and I get to bring it out front and multiply it. So this is 7 times the log of 24. Okay, so I'm going to run into the same problem that I had before, and that is I can't take the log of 24 from my log table because I only get numbers from 1 to 10. So I need to turn 24 into scientific notation. That's not a problem. So this is 7 times the log of 2.4 times 10 to the first. Okay? Now I need to break up this portion as using the product property. So 7, and I'm going to put this in parentheses, log of 2.4 plus the log of 10. And the log of 2.4 I'm going to look up on my log table. So take a look here. So 2.4, this is 0, 1, 2, and so on. I just need this one here. So the log of 2.4 is equal to 0.380. 0.380. So this is 7 times 0.380. And what's the log of 10? The log of 10 is just 1. 10 to the first power is equal to 10. And inside the parentheses, just add the 1, and we have 7 times 1.380. So now I just need to do that multiplication. I'll do that over here on the side. 1.38. I don't need to put that 0 there. Multiply this times 7. 7 times 8, that's a 6. Carry the 5, that's 56. 21 plus 5 is another 6. Carry a 2, 7, 8, 9. And then I need to move my thing over 2 decimal places. Do you remember this whole multiplication thing? Of course you do. So this is 9.66. Oh, that's ugly. Let me fix that for you. Okay. Again, this is an answer to a logarithm. Answer to a logarithm is an exponent, and specifically on 10, common log base 10. Okay. So what we're looking at here is 24 to the 7th power is, well, I'm going to say it's approximately equal to, because we're only working with a couple of significant figures, 10 to the 9.66 power. So as we've seen before, we cannot look up 9.66 on our table working backwards, because working backwards we only have numbers from 0 to 1. So I need to write this in scientific notation. That's 10 to the 9th times 10 to the 0.66 power. Because, like bases, I add the 2 exponents and I would have 9.66. I'm just going to go ahead and put a 0 on the end of that because remember there are 3 decimal places on the log table working backwards. So I have this set up for us right here. And 0.660 is in the 4.5 row. And this is 0, 1, 2, 3, 4, 5, 6, 7. So 10 to the 0.660 power is equal to 4.57. Now what else did I have on there? That was 10 to the 9th, so times 10 to the 9th. And honestly, you don't have to move that decimal place over 9 places. You can leave it just like that and be done with it. Alright, thank you, good night.